Let's move on. The diagram shows a circle ABCDE with center O, where BE is parallel to CD. Angle EAD is 35, angle ADC is 48, angle BED is what they want you to find. They did not label the angle, so you just label it yourself. So where is BED? BED is this angle. Okay. By the way, every year I got students ask me, there's this thing that you learn in A-Math called alternate segment theorem or your tangent chord theorem. Can you use it in E-Math? Yes, you can if it's applicable. In fact, there was a year where the question was very easy because for 3 marks. But if you apply tangent chord theorem, then you get the angle instantly. It was a very strange question. All right. But of course, it's 3 marks because your E-Math students wouldn't know how to apply your alternate segment theorem. Now, let's look at this diagram. So you are given the 35. Anytime you are given angles like that, you look for angles in same segment because you got angle lying on the circumference. Either angles in same segment or angles in either angles in same segment or angles in at center. But you notice that in this case, be very careful. Center is O. Not all the lines pass through the center. So be very, very careful. Sometimes it's useful to draw from points to the center. Sometimes it's not. It depends on the question. So it's also quite hard to tell. Now, anytime you get center, what should you draw? Indicate the radiuses. So for example, this is your radius. This is your radius. This is also your radius. Okay. So from here, you can see that triangle COD is actually an isosceles triangle. May or may not be useful. So let's ask ourselves, EAD is 35. So where is the angle in the same segment in this case? Here. This is bound by the arc, minor arc ED, right? And this is bound by the minor arc ED as well. That means this angle and the 35 are angles in the same segment. Okay? So we can go ahead and find that. So angle ECD is equal to angle EAD, which is equal to 35 degrees because angles in same segment. Please do not shorten the word segment. Some of you like to write SEG. No, not acceptable. Okay, so 35 degrees, label it. Next, from here, again, like I mentioned, we have an isosceles triangle. That is one. Okay, but the question wants you to find which angle? The question wants you to find angle BED. But anyway, I'll draw in the isosceles triangle first. Take note that if you find more angles than what is necessary for the question, doesn't matter. Finding more is fine. Finding less is not. What other angles we have? The other kind of angles to look for is angles in semicircle. Alright, specifically your right angle in semicircles. So do we have any semicircles? If AD is your diameter, you know AD is diameter because it tells you center is O. So AOD is a straight line. That means you have a right angle somewhere. Okay. So you will get this angle is a right angle. Write it down. Angle AED equals to 90 degrees cos right angle in semi-circle. Okay. So obviously they gave you this parallel sides for a reason, right? If you look at this, if those two lines are parallel, your angle BED and this angle would have parallel sides. And so the next angle you should find is angle AD. So angle ADE is just 180 degree, minus away the 90 degree that we found, and minus away your 35 degrees. And that will give you 55 degrees. This is your angle sum of triangle AED. It's not necessary to label the triangle, but I just like to label the triangle. And if you find that this is 55 degrees, write it in. So does that allow you now to go and find your angle BED? Yes. Using the green color cut. Angle BED is equal to 180 degrees minus 48 degrees minus 55 degrees, which will give you 77 degrees. Again, make sure you write your reason. This is parallel sides, right? So interior angles, and then state which pair of parallel lines. In this case, BE parallel to CD. Very important. Okay? So you notice that I found one extra angle that I didn't need, but it doesn't matter. Just leave it. Interestingly, so you all ask, so if is something needed for part B and then I found in part A, will they still give you credit for it? Yes, they will. Of course, you want to be very safe to make sure the examiner doesn't miss it. You cancel it and you write it in part B, or you don't even need to cancel it, just write it in part B again. It's fine. Okay. So I already found angle ECD just now. So to find angle BCE, let me now use red. BCE is this entire angle over here. I'm going to draw a big one because it's not very hard to see. So very clearly to find BCE, you know that you need to subtract away this angle. Or at least that seems to be the case. You need to find your entire BCD. Or you would want to find OCD. Correct? It makes sense to find angle OCD in this case. I already found ECD, so it makes sense for me to find OCD. And in this case, I can find angle OCD because of the isosceles triangle. So angle OCD is equal to angle ODC equals to 48 degrees because base angles of isosceles triangle OCD. The triangle doesn't have OCD. Yeah. Laugh at my joke now. What a false laughter. Okay. So we have found OCD, we have found ECD, and therefore we can find OCE. Correct? Which angle they want me to find? Oh well. They want BCE. Okay, so actually I didn't do it that way, but it's fine. They want BCE. This one, yeah, don't ask me what I was doing. What do we call this? What do we call this thing? It's a cyclic quadrilateral. Okay, so whenever you see a cyclic quadrilateral, marked by the fact that all 4 points of the quadrilateral lie on the circumference, normally you're using angles in opposite segment, which is just what I should have done, but I found a bunch of other extra angles. It's fine, just leave it. Some of you have a habit of erasing it, don't bother. Okay. So from the cyclic quadrilateral, actually, if you think about it, I can find the entire BCD because I already found BED in part A. So I can find the entire BCD. So angle BCD. So actually, angle BCD is just 180 minus what you found in part A, which is 103 degrees because angles in opposite segment. Alternative reason, opposite angles in cyclic quadrilateral, whichever reason your school taught you. But you notice that either one you must write opposite. A lot of you miss out the word opposite, you get 0. Okay, so either the blue reason or the red reason is fine. Just write one, don't write both. So you find BCD is 103, you should be able to find BCE now because it's just 103 minus 35. This one don't need reason. So you notice that I found a bunch of angles that I didn't need. Okay, specifically, I don't need this angle. You know why I found it? Because OCD. Laugh. I made the same joke twice, so you must laugh. Next. Radius of the circle is 5 cm. Calculate the area of the major sector, please. You must know what the major sector refers to. What is a minor sector? So I'm just going to draw a separate circle to illustrate the information. So I have a circle. I have the center of the circle. I draw any two lines from the center of the circle to the edge of the circle. So let's call this A, let's call this B. Okay, so for example, So you will obviously notice that there are two angles here. What is a sector? This is called a sector. So that's called the center of the circle. Oh, forgot to label. So you see the red color part. This is called a minor sector. Why is it called a minor? Because it's smaller. Now, there are actually two sectors here, right? You have the sector AOB, which is a minor sector AOB. You also have this thing called a major sector. Obviously, from the diagram, if I just draw it like that, you can see why one is called minor, one is called major. So the minor sector is determined by the smaller angle. The major sector is determined by the larger angle. Okay, so that is what sectors mean. Then the other thing that sometimes students get confused by is what? If I draw a line across like that, this is called a segment. Okay. Then what is an arc? So this line here is called an arc. We call this the minor arc AB. And then obviously the one on the flip side, this one, we call it major arc AB. So you realize that they are the same letter one, just that one is called minor, one is called major. So you cannot just tell me arc AB actually, because arc AB can be minor, can be major one. You are supposed to state whether it's a minor arc or a major arc. Of course, generally by convention, if you just tell me arc AB, we assume that you are referring to the minor arc. So you normally only state when you're referring to the major. Okay? But don't confuse your terms. Make sure you know what's a segment, what's a sector, what's an arc. Okay? So now the question tells you that you want to find the major sector OAEDC, which is the part that is shaded here. That is your major sector. Okay? Because AOC will be the minor sector. So you must know what they want you to find. So some students got this question wrong because they don't know what the major sector refers to. So it's the part that is shaded there in pencil. That is called your major sector. So how to find the major sector? You should know how to find area of a sector. So your major sector will be bound by the reflex angle AOC, if you realize. So the area of the major sector is determined by this angle. So it's angle AOC, but the reflex angle AOC. Okay? So how do we find angle AO? Reflex AOC. You should recognize that if AOD is a straight line, this is just an angle on the straight line, right? So all you need is to find angle DOC. Okay? So this angle extra that I found needed to be used here. Okay, wow. So your angle OCD equals to your angle ODC equals to 48 degrees. The reason being I just want to find what is COD now. So angle COD is equal to 180 minus 48 times 2. To give me 84 degrees. This would be your angle sum of triangle OCD. And therefore, reflects. Please must write the word reflects. If you just tell me angle AOC, again by convention, when you just write the angle, you're referring to the obtuse angle. You're not referring to the reflex angle. So you have to tell me reflex angle AOC is equal to 180 degrees plus 84 degrees to give me 264 degrees. Okay? Maybe I should just copy this down here. Wonders of technology. All right. So once you have found reflex angle AOC, you should know that area of a sector is angle over 360 if it's in degrees. Okay, if it's in radian, it's slightly different. Your radian is your half r squared theta. That is given in your formula sheet. But in the formula sheet, they also specify that that is when theta is in radians. We are not finding theta in radians here. We are finding it in degree. So you just remember area of a whole circle, then you find the percentage or the proportion, which is 264 degrees out of a full circle of 360. So area of major sector, what name did they give it? OAEDC is just equal to 264 degrees out of a total of 360 degrees times pi r squared. And they tell you that r is 5 cm. Please read the question. So times pi r squared, which will give you 57.6 in 3SF. You all notice this year paper 2021, when it's in units, they give you the units. I don't know whether you all noticed that. The previous question, they gave you units squared. But in 2022 and 2023 papers, when it's in units and units squared, they never give you the unit. Very strange thing. Even Cambridge is very inconsistent. Or a little inconsistent sometimes for some weird reason. Of course, angles, you notice that consistently they don't put units. But you notice that things like units, length in units, area in units squared, sometimes they give, sometimes they don't give. Strange thing. Okay. If you are wondering what I was talking about, I'm talking about this question. The area here, they give you unit square. But in 2022 and 2023, I don't think they gave it. You are supposed to write the unit square yourself. Strange thing. Okay. So please, don't confuse your radian measure formula with your degree measure formula. Whether you are finding arc length or whether you are finding area of a sector is different when it's in degree versus when it's in radian. The formula differs slightly. Don't be confused. The formula given in the formula sheet are always in radian, not in degree. All right.